The most important aspect of American industry is it moves. Yes, American industry is constantly on the move, and that motion is planned motion. It's called material handling. Now, there have been many attempts to define material handling, and they all boil down to simply material handling means handling material. The secret to an efficient, cost-effective system of handling material, a system which moves the right quantity of material to the right place at the right time, is in the planning. Now, this model is typical of a manufacturing plant layout, and that's where the planning starts. Here, at the receiving dock, the planner must consider the mode of transportation delivering the raw material, its configuration, and the volume. From receiving, the supplies move into storage to await their need in the manufacturing process. Movement from storage into production also requires planning and specialized systems. For here, the raw materials and parts must truly arrive at the right place at the right time, as well as interface with the machines and systems of the manufacturing process. These same needs for material handling are found throughout the plant, as parts and subsequent assemblies must be efficiently moved from one workstation to the next. When the manufacturing process is complete, the finished goods go into the warehouse to await the sale and shipment to the ultimate consumer. And here, the finished goods are pulled from the warehouse and moved to the shipping dock, picking the right goods at the right quantity to meet the order. Our model layout ends here at the shipping dock as the order of finished goods is loaded for shipment. Now, of course, material handling is not just limited to the manufacturing industry. You'll find material handling in all sorts of applications. In fact, wherever material has to move. So let's use our model here to introduce some typical and not so typical examples of material handling systems and equipment. Let's start with the material handling related to receiving materials which arrive at the plant. Here's a counterbalance lift truck with a special clamping device for handling large paper rolls received at the plant by rail car. And here's a more conventional electric forklift truck handling palletized unit loads received by motor truck. At this cotton warehousing operation, bales arrive by flatbed truck and are offloaded by a special clamping lift truck to the immediate ground area prior to grading and storage. The uniqueness of this clamping device and the skill of the operator driver combine to rapidly handle a high volume of bales. Here's a waist-high belt conveyor being used to offload parcels from a postal service van. Now, obviously, this is not your typical plant receiving dock. This is a huge and sophisticated cargo container operation where dockside cantilever crane and hoisting equipment is used to lift and move the containers to the dock, where they're picked up by a straddle-type van carrier. then moves the container to temporary storage. But offloading and receiving, regardless of the situation or the type of material handling equipment employed, is just the first step that needs to be planned for. In most operations, receiving handling include quality control, sorting, and inspection to ensure conformance to the order. Then the material moves into storage. Typically, a manufacturing plant like our model here would use a lift truck like this to move pallet loads into storage. A unique replacement for the pallet, providing lower cost and higher density storage for some applications, is this slip sheet made of paperboard. Loads stacked 4 or 5 high demonstrate the obvious savings in numbers of pallets and vertical storage space. Now, while use of the basic lift truck to place palletized loads on storage racks is the conventional approach to getting materials into storage, material handling engineers have designed a number of specialized systems for this step in the process. Here, for example, is a side-reaching industrial lift truck carrying wire containers of received parts onto rack storage. The combination of a high mast and scissor-action fork allows this vehicle to operate in high-density, narrow-aisle storage areas. The requirements of moving bulk materials into storage provide a real challenge to the materials handling industry. Here, coal is moved by a continuous conveyor belt into temporary hopper storage. At this ready-to-wear clothing warehouse, boxed product is received for further processing. This includes weighing, tagging, and sorting. And it's all accomplished continuously by a carefully designed network of belt and roller conveyors. When you receive 3-ton coils of rolled steel, you may need a ram-equipped lift truck like this. Notice the massive rear suction designed to counterbalance the heavy load. Some of the most sophisticated examples of material handling today are the automatic storage and retrieval systems. Commonly referred to as ASRS, these computer control systems handle palletized unit loads with an automatic courier. They employ a variety of complex mechanisms for alignment, position checking, and precise control to assure deposit of the load at the prescribed storage bin location. But thanks to their computer controls, ASRS systems go both ways. They provide rapid and precise retrieval of stored material needed for production. And that's the next aspect of material handling we'll look at, moving goods out of storage to the production floor. As with other aspects of material handling, the size and configuration of the material dictates the handling equipment required. This overhead crane moves huge steel plates from storage to the production area. But whether your materials are large or small, efficient material handling will get what's needed into production on time. This narrow aisle lift truck features a fork that can swing 180 degrees, reaching either side of the aisle to efficiently retrieve palletized loads. When bulk materials are required in the production process, specialized equipment is frequently brought into play. But production and manufacturing operations aren't the only applications for efficient handling of supplies. This large metropolitan hospital relies on a unique wheeled cart and overhead conveyor system to move medical supplies to the hospital floors. The right material to the right place at the right time. Obviously of critical importance in a hospital. But let's look at the middle section of our plant again. We've moved supplies onto the production floor, and now it's time to manufacture. Time to convert raw materials into parts and components. And here, material handling again plays an important role. If your manufacturing involves heavy materials, you may employ a jib hoist like this. It can move in 3 dimensions. The jib hoist rotates, booms, and lifts within its prescribed area. The most common method of moving parts between production work centers is by rider and walkie-type lift trucks. When sufficiently high volume is required, conveyors are utilized to move parts between production stations. All production work centers need tooling, and on a heavy operation like this one, an overhead hoist and track system is used to move a large die to the waiting production machine. Through careful economic analysis, high volume justifies the design and installation of complex automated manufacturing handling systems like this piston machining operation. Notice the variety of intricate transporting and sensing devices that have been incorporated. A manufactured component part. And our next material handling job is to move such parts through assembly and produce the finished product. Fixed path and continuous material handling systems play a major role in most assembly operations. If, for example, you're assembling and finishing these toy trucks, one required handling step would be the application of paint. At this toy manufacturing plant, an overhead conveyor is used in a continuous dip painting process. While another conveyor rotates toys through an electrostatic spray unit. moving bin conveyor system transports component parts to the assemblers. Following completion of the task, the subassembly is returned to an open bin on the conveyor. Over the years, the automotive industry has led the way in the development of complex, continuous assembly systems. The demand for low-cost, high-volume assembly lines requires the use of a variety of material handling components. Belt and overhead conveyors, electric and air-operated hoists, and a number of specialized rolling carts and fixtures are integrated as literally hundreds of components and subassemblies flow together, and the finished automobile emerges. The assembly line has indeed come a long way since Henry Ford's Tin Lizzie. Well, finished cars can be driven away, but most manufacturing operations require warehousing of finished goods prior to sales and shipment. A variety of material handling equipment and systems are employed in these warehousing operations. Here's a driverless tractor tow cart system used to move finished goods from the manufacturing area into the warehouse. It moves along prescribed routes, following white, light-sensitized tape, stopping at pre-selected stations for the unloading operation. In other applications, a wire is embedded in the floor to electronically guide the tractor. In recent years, warehousing operations have gone to high-rise, narrow-aisle configurations, and with them have come a whole family of specialized lift trucks like this. Here's what looks like a pretty conventional lift truck serviced warehouse. But notice the roller bed and the rack area. These flow racks allow the scissor action of the truck's fork to continue to load several pallets from the same position, while orders are picked from the opposite end of the rack. At this typewriter factory, a power and free type conveyor system continuously moves finished units directly from the assembly and inspection lines to packaging and warehousing. Here's a unique piece of material handling equipment, a palletizer. It receives case lots directly from packaging and automatically orients them to the appropriate pallet size and configuration. No manual handling required. For large warehousing requirements of light goods, this animated model of a totally automated, high-density storage system shows the system's capability for handling high volumes. The absence of aisles allows virtually total density warehousing as the program transfer vehicle fills row after row with finished goods. Here's the real system, applied to the requirements of warehousing thousands of automobile seat cushions. This large warehouse encompasses 71 lanes of storage, but is served by only 2 of the busy transfer vehicles. Not unlike the automatic storage and retrieval systems, the transfer vehicle can be programmed to retrieve finished goods from the warehouse. The movement of warehouse goods to shipment is the next aspect of materials handling we'll look at. For rapid and efficient response to orders is a critical element of a good warehousing retrieval operation. Here's a radio-controlled tractor and cart system being used in order filling. The operator's radio control unit allows him to walk or ride between his required stops in the warehouse. Select the right location number, and this unique carousel system at a parts warehouse rotates the desired part bin right to the operator station. The order is filled and placed in a tub for subsequent packaging and shipping. This order-picking vehicle is routed to the required bin locations by a pre-punched deck of cards. With the release of the first card, the vehicle automatically moves to the prescribed location while the operator notes the item and quantity. After the pick, he releases the next item card, and while en route, has time to sort and batch the order. Now here's an industrial lift truck that's been especially designed for order picking. The operator's drive station moves up and down with the mast and is adjacent to the pallet load. These automated feeders are where it all starts when an order is filled in this large grocery chain warehouse. Roller and belt conveyors transport the cases of goods to several cart loading stations. Ultimately, the loaded carts are moved by rider tractors to motor vans for their trip to the store. But the motor truck is just one method of shipment of finished goods. To load other means of transport and other configurations of finished goods requires other material handling systems and equipment. Here at our model plant, we're using a combination of roller and belt conveyors to move our packaged goods to transport. At this frozen food warehouse, belt conveyors feed a sorting carousel where the loaders pick off the cases marked for each individual shipment. Here's a huge traveling crane handling large palletized loads at a covered dockside lighter and barge loading facility. Since most shipping today is by rail and truck, the loading and handling represents conventional applications for lift trucks and unit loads. The ship and barge modes of transportation, however, have generated some massive handling systems, like this cantilevered bridge crane for loading heavy steel plate. Bulk loading requirements, such as this grain car loading facility, can handle huge volumes quickly and efficiently, thanks to systematic engineering of the entire operation: elevators, conveyors, and hopper cars. Well, there you have it. American industry on the move with planned material handling. The right equipment to move the required materials to the right place at the right time. Now, these have been just a few examples of the diversity of applications in the material handling field. Hopefully, we've sensitized you to look for other examples of material handling. They're all around you.